Okay, so the math professor on this podcast, whose name I just blanked on last video, was Mariel Vasquez of UC Davis. And she explained, as an example, what happens when you have a linked DNA that has 6 crossings. So I'm not even going to attempt to draw it. But so you have one link of DNA here, and then another one that crosses.
A lot.
A lot, yeah. A lot's probably the right word. And then like that. Okay, so here we have 1, 2, 3. Oops,
those would just.
Yeah, sorry, I got it wrong. All right, so it does that. And what was the mechanism when you had these? Here we have 1, 2, 3, 4, 5, 6. Oh, jeez. 6. That was the example she used. What was the mechanism, she said, for how these enzymes help unlink this? What do they do?
So they just erase the crossings. So they make them into one continuous loop and then separate them into 2 things but with less crossings, and then repeat that until you eventually get to the just a circle, and then you can pinch that circle and get two circles of what we want.
Yeah, and through that, she said you actually started with a link with 6 crossings.
Yeah.
And then when you went down to 5 crossings, what did you have?
It'd be a knot.
A knot with 5 crossings. And then you have a link with 4 crossings.
A knot with
3 crossings. And you remember what the knot with 3 crossings is called?
a trefoil.
Trefoil knot. And we've studied the trefoil knot before. I have a couple of... This I did prepare for ahead of time. I have a couple of... trefoils. Here's one trefoil, and then here's another one where you can actually draw the trefoil on a torus. But I thought it would be fun because you go from a trefoil knot, which has 3 crossings, down to 2.
A link.
A link with 2 crossings, and you know what that's called? Do you remember what that's called?
Just the
Is that called the unlink?
No, it's got 2. If it's got 2 crossings, it's going to be circle, and this one's going to go under and then over.
So
It's just the trivial link.
Yeah, it has a name. This trivial link, this most basic kind of link, is called the Hopf link.
Hopf link.
And then what comes after?
So that would be the trivial.
The trivial knot or the unknot.
Okay, and then
0 crossings, which we
And just 2 circles.
Separates apart.
yeah. Okay, so let's see if we can do that using our old
Why not book?
Why Not book and the link that came with it. So let's study this. So first, we have made ahead of time
A trefoil.
a trefoil. Can you count the crossings for me on this?
1, 2, 3.
Okay, now when you go from 3 crossings to 2 crossings, this is what I wanted to study here. What happens? So we're going to break a crossing. Let's break this one.
Okay.
But before we break it, let's talk about what we're going to do after we break it. What's the mechanism we're going to do to break this crossing?
So we're gonna break that crossing, but we need to connect it
Okay.
with something.
How? How are we going to connect it after we break it? And even more basic, what are we going to do when we break this?
So we just break it here. We need someplace to connect that.
Okay.
Those 2 ends to.
Yeah, so if I break it like this, I need to connect them and to have something that only has 2 crossings now. So
Well, connecting them under, we've got.
if you connect them under, it still creates a crossing.
Well, but
Don't move it. So we break that, and if I connect it under, I still have a crossing.
would you connect it just to, like this?
Well, there's no way to connect to there right now.
Well, we could break it here as well.
And then you can connect those 2.
Interesting.
And that's how you get the link.
Okay, so let's break it there. And how am I going to connect this so that I don't have a crossing?
So orange to orange and black and purple to purple.
Okay, go ahead.
And
Alright.
this gives us
these two,
This gives us,
the two circles.
okay, and do you remember what that was called?
that was the hop link.
The hop link, yeah. All right, so now can we do the same procedure here that you just did?
Yeah, we can break one of these.
So break it here.
And break this.
And then you connect orange to orange, purple to purple.
Yeah, sometimes it's hard to connect.
Well, we can use that again in our. Okay.
All right, so what do we have here?
Then we have one crossing.
Okay.
Right here.
Well, we
You
don't,
can just
but it's
flip it
not a
over.
crossing.
Well, no. So that's right. We have one crossing here. Now the enzymes are acting on this, so the enzymes don't get to grab the ends of this thing and break it like that. So what?
So we can just break this crossing.
Okay.
There we go. There.
Okay.
And then I guess we have 3 oranges here, but
Okay.
and that gets us our 2 pieces of circular DNA.
So there we go. Now, do you see any problems that might arise through the
Well,
procedure we just did?
These aren't the same size.
Okay, these aren't the same size.
And plus, we've got these strands like here. We've got 2 purples. We have 3 purples here. We've got a couple strands like that in here.
Yeah, yeah. Is it a problem if your DNA turns purple?
Well, it's a problem. If these 2 things represent different things, then having 2 of them next to each other could be a problem.
Yeah. So what does that tell us about this process?
It's a very delicate process. You have to do it in exactly the right spot.
Yeah.
Otherwise-
Yeah, this is not a super duper simple process. Even though, as she explained it, it sounded pretty simple. But even just doing it with our I don't know what this thing's called, a tangle, I think he called it, from the Why Not book, we can see that this process is a little bit more delicate than it seemed.
Yeah.
Okay. All right. Let's go on to one more knot project.